This conference will now be recorded.
So very good evening, students. We are back with the discussion of the questions from previous year's JEE Advanced Papers and on the topic magnetism. So we have few questions today. We'll discuss those and try to understand. So the first question is related to galvanometer. Let us read the question first. Consider two identical galvanometers and two identical resistors with resistance R. If the internal resistance of the galvanometers, this is RC, suffix C, RC less than R by 2, which of the following statements about any one of the galvanometer is or are true? Okay, so the options are: the maximum voltage range is obtained when all the components are connected in series. So this is first option. Let us see the second option. The maximum voltage range is obtained when two resistors and one galvanometer are connected in series and the second galvanometer is connected in parallel to the first galvanometer. This is second option. Okay. And third option, the maximum current range is obtained when all the components are connected in parallel. The fourth option is the maximum current range is obtained when two galvanometers are connected in series and the combination is connected in parallel with both the resistors. Okay, we'll see one by one. So the first option, the maximum voltage range is obtained when all the components are connected in series. So look, when we connected all of them in series, what happens to that? Okay, all the all the components, when we connect them in series, what is happening over there? So we have two galvanometer which has internal resistance RC, both of them, and two resistors are there. Okay, so actually internal resistances are RC and this R and R, these are actually RG. Okay, RG means here it is given R, and internal resistance are RC. Okay, so when we do this, all the components are in series. So what is the maximum allowed current through them? See, maximum allowed current through them is just Ig. Okay, so the maximum in this case, maximum in series, because the galvanometer will be damaged otherwise. Okay, so maximum current through the galvanometer is Ig, right? Ig, I am writing a small letter Ig. So we can understand that throughout this the current will be Ig only. Okay, all right. Therefore, what is the maximum voltage range we get here? The maximum voltage range in this case in series, what we are getting? We're getting as 2. Okay, let me, okay, 2R. So I into R, right? 2R plus 2RC. Okay, if I take this common and Ig is the current, so this is the voltage range you get, isn't it? This is the voltage range we get. Okay, let us see. This is one way to get the voltage range maximum, or like we are getting voltage range is equal to 2Ig into R plus 2, R plus RC. So this is one way to do. We have another way. Maximum voltage range will be obtained when two resistors and one galvanometer connected in series. So that part also will do. See, one galvanometer and two resistors are in series, and the second galvanometer is connected parallel to the first one. Let us draw the circuit diagram. The circuit diagram says, suppose we have, this is the galvanometer with internal resistance, RC, with the galvanometer internal resistance RC. Okay, now connect two resistors. Okay, two resistors R and R in series, and see the second galvanometer having the same resistance is connected in parallel with this one, the first galvanometer. Okay, this is first galvanometer, this is second galvanometer, it doesn't matter. Okay, so now look, both the galvanometer, see here actually both the galvanometer will allow only current Ig. Okay, here also Ig, right? Whatever current it may be. So this is actually 2 Ig. Okay, 2 Ig. So that Ig current 2 Ig will be divided into Ig and Ig, right? I hope you understand this. So in this case, the voltage range, let us say Vp. So in this case, what we get? What we get? So this is 2 Ig. See, in this case, we have two resistors, RC and RC. Okay, so if you just multiply RC square divided by 2 RC, so you'll get actually RC by 2. Okay, and these two guys are actually, see, I'm just writing here. So it will be 2 Ig, or let me just first find out what is the combination. Okay, RC by 2 plus 2R, right? So along with that, 2 Ig is the current flowing through this. Okay, so the voltage range you get here is RC plus 4R into Ig, right? Look now, if we take the ratio of this Vs and Vp, we'll get a clear picture. Which one is greater or which one is maximum? Okay, let us see that. So we'll write Vs by Vp. So Vs we obtained 2 Ig R plus RC, and here we are getting Ig here RC plus 4R, right? Now if we we can strike them out. Okay, let us do a little bit of simplification here. Actually we would do otherwise, because this is greater one, we'll just do otherwise. Vp by Vs will do. Okay, I have a page, no. Okay, we'll go to the next page and do the solution. Vp by Vs, it is actually Ig Rc plus 4R, and here it is 2Ig Rc plus R, right? So let us just do this, and if we okay, we just do this, R plus 3R divided by 2 into R plus Rc, or Rc plus R. This we have, right? So what we can do here is, see, Rc plus R, this part we'll just take along with this, so we'll get half plus 3 by 2, this is R by Rc plus R, right? 3R by Rc plus R. So 3 by 2 is 1.5 anyway. So now see, there was a condition that Rc is less than R by 2, right? Rc is less than R by 2. At least if we take Rc is equal to R by 2, let us take just for the time being R by 2, then look, this is this, and Rc is R by 2, this is R, this is R by 2 and plus R, so 3 by 2 R. Okay, so we get, see, sorry, we get half plus 1, half plus 1, that means 3 by 2. Okay, so we can see that Vp is greater than Vs actually. Okay, because this Rc is less, okay, less than R by 2. Rc is less than R by 2. If you look here, Rc is less than R by 2. We have taken more. Actually, look here, it is greater quantity. Here it is actually Rc is less than R by 2. Less than R by 2. That means this quantity will be at least less than 3 by 2 R. That means it will contribute to 1.5 plus something. So we can see that Vp will be greater. Okay, Vp will be greater than Vs. At least that's what we can say. From here we can say Vp is greater than Vs. Okay, that means which option is correct over here? The second option is correct. The maximum voltage is obtained when the two resistors and one galvanometer are connected in series, and the second galvanometer is connected in parallel to the first galvanometer. Okay, so this was the first part. Okay, so two options we have seen. Another two options we will see. So this option says maximum range is obtained, maximum current range is obtained when all the components are connected in parallel. Let us see. And the second one is maximum current range is obtained when two galvanometers are connected in series and the combination is connected both in parallel, connected in parallel with both. Okay, we'll see this two also. So let me just clean this. So in this case, what we are getting, look, first case I'll see. So first case, all the components are parallel. Okay, this is one galvanometer. All right, so another galvanometer. Now all the resistors like this. So this is R, this is R, this is RC, this is RC, right? Look here, in this case, see the galvanometer will allow only IG and IG, right? They will allow only IG and IG current, right? So this current, if I say this is the primary current, IP or parallel current, the total current will be how much? Or we need to see the current range, right? So this current has to be, see, so this IP has to be 2IG, we know that, okay? So 2IG, 2IG, 1 plus RC by R. I hope you have understood this. See, the current IG, if I just take this is IG, this is IG, so 2IG, all right? And here the current will be, see, with this the current will be actually IG into RC by R, okay? RC by R. See, so this is the current through both of them, RC by R. So that's why this is 2 into this and this is 2IG, okay? In the second case, we'll see in the second case or the last option. What is the last option? The current is maximum current range is obtained when two galvanometers are connected in series and their combination is connected parallel. Okay, so these are series, galvanometers are in series. So through this there will be only IG. These are RC, and both the resistors are connected parallel to this combination, okay, parallel to this combination. Okay, so this is R, this is also R. Okay, so in this case, you get the total current. In this case, suppose this is the series current. How do you get the current? So current you get here, IS is equal to I is equal to 4 RC by R into IG. Okay, so you might be thinking how we are getting this, because see, you can just check from here if these are in series. So 2 RC will be the total current in this, and so the voltage drop is IG into this. So this is the voltage drop for these two guys also. So what will be the current? This will be the current in each, right? So this will be current in each case. What we get here, 2 IG into RC by R. So this is the current in each of them. So it will be 4 IG in these two, 4 IG RC by R. So in this case also we would have done like that. Okay, so this is Ig into RC. This is the voltage drop across this also divided by R. So this is the way we can actually find out current through these two guys. Okay, so this will be Ig RC by R. So this is the way we find out the current through these two, because the voltage drop is same for all of them. Okay, this is how we have found out the current range. Okay, I hope it is clear to you. So we have obtained the current range for both the cases. Now we'll see and compare. We'll just compare and see which one is greater or maximum, which one is giving maximum range. Look, this case I'll just go with IP by IS. If I go by IP by IS, see, IP is 2Ig whole into 1 plus RC by R. Okay, actually IP, what, how do I write IP? IP I have written Ig plus Ig plus Ig into RC by R plus Ig into RC by R. This is how I have written this IP. Similarly, here I have written Ig plus, see here I have written, see Ig through this, and through this it will be 2Ig, because RC plus RC, so 2RC into Ig, so 2 RC Ig, so 2Ig by RC by R. This is the current through both, 2Ig RC by R. This is the current through both. So this is the thing I have just added up. Okay, Ig plus this plus this. So that's how I got this. Okay, anyway, now I'll write it here, IP by IS, right? So this is IP, this is IS. So IS is actually Ig whole into 1 plus 4 RC by R. Okay, if we simplify it, we'll get some idea about it, isn't it? So let us see how we can do this thing. We can further, let us go to some other page to do this calculation, because it is lengthier calculation. Okay, so I'll write it here again, IP by IS. So IP, what we got, 2Ig RC by R, 1 plus RC by R, 1 plus RC by R, and here we have got Ig and 4RC, 1 plus 4RC by 4RC by R. Look, if we just strike this out and write R plus RC, and in the denominator also we'll write R plus 4RC, right? So now we'll do the same fashion what we had done earlier, R plus RC divided by R plus RC plus 3RC, right? So these two guys, we'll just see if we just divide with this, so we'll get 2, and here we'll get 1 plus 3RC by R plus RC. Okay, look here, in this case RC is less than R by 2. If we just take R by 2, so then we get 3RC, this factor 3RC divided by, okay, 3RC, here we'll take R by 2, right? So 3R by 2, then here also we'll get 3R by 2, at least 2 we get, 1 1 2. So these are, this actually seems like, let me just see once again. Okay, So we are here now. So what we get actually, okay, so IP by IS. Okay, let me just clean some portion here, or maybe go to the next page somewhere here. Okay, so here in this case we look what we get actually. IP by IS, if we do the simplification, what we were getting, see, half. So what we got, IP by IS, we got actually, if you look back, we were getting 2 R plus RC. We'll just redo these things again. This we were getting. Now we'll do a little bit of simplification. Okay, okay, we'll do in different way. Let me just show you what we're doing now. R plus 4 RC plus 3R. Okay, if we do this, because we have just made it 4R. Okay, 4 RC, and this R. So we have actually made 4 RC and 4. Actually, we have just multiplied by 4. Okay, or we have taken two common again, so that it will be, or divide, yeah, so that it will be 4, and that is multiplied here. Okay, so we have actually multiplied by 2 in the numerator and divided by 2. Okay, that's what we have done now. Okay, so now here it is 4 RC in the denominator. So this guy will go anyway, you know that. So half is down. Okay, half is here, and then this is 1 plus 3R by this R plus 4 RC. Okay, so now if RC is less than R by 2, then see 2 RC 2 RC is less than R. Okay, this we know. Or we can do one thing. The 4 RC is less than 2R. This is also can do. Now look, if we say R plus RC, R plus 4 RC, what about this? See, 4 RC is less than 2. That means this must be less than actually 4R, right? 3R, sorry, less than 3R. I hope you agree with me. See, this is the condition. So RC is less than R by 2. So 2 RC is less than R. Then 4 RC is less than 2R. So what about this then? R plus 4 RC. That means this is less than 2. That's why it is less than 3R. Okay. So R plus R, this is less than 3R. So I can say then from here 1 plus, this is actually a quantity. If this is less than R, sorry, less than 3R, this is actually greater than 1. This term is greater than 1. Okay, this term is actually greater than 1. Okay, so if that is the case, or at least we can see this is actually 1 plus of something. Okay, it is not less than 1. At least this is actually greater than 1, isn't it? So from here, okay, one more thing I need to understand from here. Okay, just 1 minute. So if this is this, so we will take actually 1 plus R by RC, 4RC. This is actually greater than 3R. This also is another inference. Okay, even if it is this, then also at least we have, see, we have here a quantity which is actually less than 1. If it is 0.23, at least this also, then also it is 1 plus some quantity, right? 1 plus some quantity. That means IP is actually greater than IS. Okay, so this is the actual conclusion, that if you just do this thing, so you will understand that this IP is greater than IS. Okay, so this is a very nice question, and you look the answer B and C is actually in parallel. When all the components are in parallel, we have seen parallel current range is maximum, okay, compared to this. So these two options are correct. So actually you will be confused to read many answers from available sources, but these are very authentic answers because we have already solved like from the basics. Okay, so these are correct answers. Okay, these are correct answers or correct option for this galvanometer. Okay, all right, so we'll go to the next question. So this is again another interesting question and very conceptual. You can just see, I'll just write the options for this. Let me just write the options. Okay, let us first read the question itself. Which one of the following option represents the magnetic field B at O due to the current flowing in the given wire segments? Okay, so this is the question. Now we'll see the options. I'll write down the options. Okay, so look, this is the geometry. I'll just make you understand while solving. Let me first give you the option. Actually, this is from JEE Advanced 2022 last year's question. So this is B is equal to minus mu0 I by L. This is 3 by 2 plus 1 by 4 root over 2 pi k cap. This is first option. Second option says B mu 0 I by L 3 by 2 plus 1 by 2 root over 2 pi whole into k cap. Option C says B minus mu 0 I by L is 1 plus 4 root over 2 pi root k cap, and option D is B is equal to minus mu 0 by mu 0 I by L whole into 1 plus 1 over 4 pi whole into k cap. Okay, so look here, there are actually several number of segments in the wire. You can check here. You have to find out the net magnetic field at O. As you see, this is the point where we have to find out the magnetic field, net magnetic field. Look, net magnetic field is due to, this is in vector notation. So I have this, suppose this is A, this is B, this is C, this part is D, this point is E, and this is F, this point, and this is G, suppose. Okay, so I have to calculate magnetic field at O due to AB part plus BC part. Okay, magnetic field due to CD part, right? Magnetic field due to DE part. Okay, and then magnetic field due to EF part, and finally magnetic field due to FG segment. Okay, so look here, if I consider this AB, BC, CD, DE, EF, and F. So EF is this card part. Okay, card part, this part. This is another arc having radius L by 4. CD, this is an arc having radius L by 2. Okay, so we can actually check if there is a possibility of becoming zero, or any of the segments contribute nothing at this point O. There may be a possibility. Let us see. I'll write the expression. How do we calculate? See, in general, B can be calculated from the formula mu 0 I by 4 pi into dl cross r by r cube. Okay, r is the vector distance. Okay, distance from the segment to the point. Okay, if this is the wire, so this is the segment. Actually, this is in general. Okay, this is in general the formula for calculating magnetic field for any current element. Okay, this is actually a Biot-Savart law. This is the Biot-Savart law, the general form of Biot-Savart law. You might know this. Okay, this is the general form of Biot-Savart law. Now look, whenever there is DL and R in the same line, then the angle between them will be either 0 or 180 degree. In those cases, the magnetic field will be 0. If DL and R parallel, look for this thing. See, this is the BC. This is the segment. I have to calculate the magnetic field over here at O. So this distance, see from here, this is the L by 2. This distance, okay, the distance and this actually this point O is actually on the line itself, on the this actually this is the point now. Okay, this is the point O. So magnetic field on the wire will be 0. Okay, on the wire will be 0. All right. In other words, the angle between this DL and R is actually becoming 0. That's why magnetic field due to BC will be 0. Okay. Let us see another segment. This one, look, this FG segment, this is also passing through this O only. Look, this FG. So magnetic field due to FG, sorry, this is not FG. Magnetic field due to FG also will be 0. Look, this FG also is having 0 angle between DL and R, current element and the vector distance. Okay, and another component is this DE. This DE also will contribute nothing. So these three components, like these three segments, will contribute nothing at the point O. So then I can just erase this. Okay, so what I get is this. So I have basically three contributions. Okay, three contributions. I would like to get this figure. Let me get this figure in the next page. So this problem is there anyway. So okay, let this deleted. Okay, so this figure, let me keep it here and see. See, I had given name A, B, C, D, up to here it is, sorry, up to here it is E, then this is F, EF, then F and G. So B net magnetic field will be obtained due to the magnetic field produced by the segment AB. This will actually contribute non-zero magnetic field at O. Okay, this guy, and this CD also will contribute to the point O. And another component we have seen, this EF, B, EF. Okay, these are three. Now look, see, this is a finite wire. This is a finite wire. You can see that this is a finite wire, and at the end point of the wire we need to find out magnetic field. So how do you get that? So this BAB, this will be actually, see, you know this formula, you might know this, mu 4 pi, and then L is the distance between this. Okay, so this is the distance, this is here. Okay, so you will get mu 4 pi L, the distance, you know this thing, I hope. This is the finite wire, right? So if you have to calculate magnetic field over here at P, then you just do this thing, okay, and get this angles theta1 and theta2, right? And this is the this is the point O. This is the point O, and see these angles, you know, like for this, actually, if this is the distance, this distance D, then we write actually magnetic field for this will be actually mu0 I by 4 pi D, 4 pi D into sine of theta 1 plus sine of theta 2. I hope you remember this formula. Now in this case, you look, when for finite wires the point P shifts here at any end, this theta 1 will be then 0 and theta 2 will be 9, in this case it will be actually 45 degree. Okay, In this case it will be 45 degree. Okay, so in general, and you look here, if this is AB part, anyway BC part is not contributing anything. So this AB part, this part, okay, look this one, okay, so this is 90 and this is actually this distance are equal, so you would get actually this is L and this is also L, so this is 45 and this is 45, okay, both are 45, that's why it is 45. Okay, so sine theta 2 will be actually 45 degree for this geometry, given geometry, because this is L and this is also L. Okay, so that's why it is 45 degree. Okay, now look, this, yes, we have to now write down what we get here. This thing is already there, so this part and this from here will get sine 45. This is fine. Okay, now what is the direction? See, this is the direction, you know, like these are all these segments are in the xy plane, as you see here it is. So the magnetic field, it is actually going downward, okay, or into the page. So into the page, actually it is outward of the page. K cap, if we take out of the plane, at least here it is taken out of the plane, okay, out of the plane, then the magnetic field will be in the negative K direction, okay, because it is going into the plane if you just use right hand thumb rule. Okay, all right, now this part is gone. We'll we used to calculate other parts. So AB, for AB we have obtained already. Okay, so we'll find out the magnetic field for CD part. Okay, CD part, and here also if you look, this will be in the negative K cap direction. At least we can find out that. Okay, the magnitude of this, how do we find out? Generally in this case, mu 0 I, say any arc, generally how we find out, mu 0 I by 2r, mu 0 I by 2r into theta, that is the angle this arc make at the center, okay, divided by 2 pi. So in this case, at least you can see this is the pi, okay, it makes angle, see these two ends are meeting here, okay, so this theta in this case actually pi, okay, theta is pi, I'll write it here, mu 0 I by 2r into pi by 2 pi, so pi goes up, so this is mu 0 I by 2r. If so if this r is the radius of the arc, in this case r is actually L by 2, so we'll write it there, so we'll write it here, 2 into L by 2. Okay, so you get what? So you get 4 L by 2. Okay, let me keep like this itself. Okay, let me just keep like this itself now. Okay, we have got this. Now we have to get for this EF part. EF is also an arc, so B, and here also it is actually minus K cap direction. Okay, and this also will be along like in the direction of minus K cap. See, I'll just write the magnitude. In this case also we'll be using this formula, same formula, mu 0 I by 2. Here R is actually L by 4, and see here angle is this angle. This angle is 90 degree. That means pi by 2, right? So pi by 2 divided by 2 pi. Okay. So what we get here? Mu 0 I. This is along again minus K cap direction. So mu 0 I. It is along minus K cap direction divided by, you look what we have here. This 2 is there in the denominator, this 2, so this is 8, this pi goes off, so 8 into L by 4. Okay, so mu 0 this thing. Okay, so this thing I can actually write sine 45 means I can write it root over 2, that's fine I guess. Okay, Now this also, if we just simplify a little bit, mu 0 I by this is 2L, okay, 2L, and this guy, okay, so let me just erase this part. We have already obtained the value. We'll directly write it. CD, this is mu 0 I by mu 0 I by mu 0 I by 2L, okay, along minus k cap direction, minus k cap, and it is, let me simplify it, mu 0 I minus k cap and divided by 2L again, right? So what we get, we'll write it here. So B, okay, so this is with minus sign. So BF, what we get, BEF minus mu 0 I k cap divided by 2L. What we get, CD, CD also with minus sign. We have got, okay, EF actually it is, yes, 2L. This is also mu 0 I k cap by 2L, okay, and this is also with a minus sign. What we get for this, we get mu 0 I by 4 pi root over 2 into, this is minus k cap again, okay. So this all I have written. Now I'll clean this portions and write down the final answer and match with the answers given, okay, or options given. I hope you have understood how I have calculated the magnetic field for each of the segments. So when you are solving the advanced question, you must be remembering formulas, because you cannot just derive them. So let me take this common, and mu 0 I by uh, mu 0 I by, let me see the options how it given, okay, mu 0 I by L, let us take this common. So we have actually here, so these two guys will be half half contributing to 1, and this will be 1 by 4 pi root over 2, okay. Look which one is matching with us, that is C, okay. So this is how we have to solve this problem, okay. So I think I will stop it here for today, uh, because there is another class in the same uh, platform anyway. So we have solved two important very important questions today, and next day we'll take a few more questions. So the option C will be the correct answer in this case, okay. Option C is the correct answer. All right, so thank you for your patience. We will meet again in the next class. Bye for today.